Data and scatter plots, our fifth objective. We're going to draw and interpret a scatter plot for a set of paired data. So researchers often want to determine if a relationship between two variables exists. To do so, the researcher collects data consisting of two measures that are paired with each other. All right. You scroll down a little bit. So one of those variables is the independent variable, and the other variable is the dependent variable. The independent variable can be manipulated, as we saw in the first half of this chapter 2, and it is known as the explanatory variable. And is called x. The dependent variable, which cannot be controlled or manipulated, is known as the response variable and is called y. The independent and dependent variables can be plotted on a graph called a scatter plot. Where the horizontal axis is labeled with the name of the independent variable, and the vertical axis is labeled with the name of the dependent variable. The coordinates of the axis are determined by the smallest to the largest data values of the variables. Right? So this might have made common sense already, but we're trying to define all vocabulary words so there is no assuming we are all on the same page now. So the definition of a scatter plot is a graph of the ordered pairs x and y of numbers consisting of the independent variable x and the dependent variable y. The scatter plot is a visual way to describe the nature of the relationship between the independent and dependent variables, even if the scales are not the same. To analyze a scatter plot, researchers look at the pattern of the points on the graph. So researchers look for positive linear relationships when the data points increase from left to right. A negative linear relationship is when the data points decrease from left to right. A curve linear relationship or other non-linear relationships, or even a no relationship at all, is when the scatters shows no pattern, line, or a curve. So again, you have positive linear relationships, a negative linear relationship. Typically, we just go with a no linear relationship, but you can also have heard of curved linear, non-linear, or just no relationship at all. So let's look at some of those situations. We got enough of these words written down. Let's look at some graphs. So here we go. So you can see right here, this would be a positive linear relationship because as I go from left to right, the dots are moving upwards. This right here is a negative linear relationship because again, as I go from left to right, the dots are moving down. This is what you would call a curve linear relationship or a non-linear relationship, because again, I can see a pattern that is curved, but it's definitely not linear. And then on D here, the data is so scattered, I can't tell any relationship. It doesn't look like it's positive, negative, there's no curve, there's no pattern at all. So this would be a no relationship. So procedures for drawing a scatter plot. As always, the very first step is to draw and label the X and Y axis. Step 2 then will be to plot each point on the graph. And then step 3 is to determine what type of relationship, if any, exists for these variables. So what we're going to look at is example 20, looking at absences versus your final grades. So we're going to construct a scatter plot for the data obtained in a study on the number of absences and the final grades of 7 randomly selected students from a statistical class. Student A was absent 6 times, made it 82. Student B, absent twice, made it 86. Student C, absent 15 times, made a 43. Student D, absent 9 times, made a 74. Student E, absent 12, made a 58. Student F, absent 5 times, made a 90. Student G, missed 8 times, made a 78. So the solution of this, we would take and draw our axis. So you can see my x-axis is the number of absences right here, going from 0 to 15, equally spaced. And then from here, I have my y-axis for my final grades. I started with 30, went up by tens, and made sure it was equally spaced as well. And then I just take that data and I just plot it. So I have 6 and 82 right here. I have 2 and 86. I have 15 and 43. I got my 9 and 74, my 12 and 58, my 5 and 90, and then I got my 8 and 78. So you can see my data. Once I've plot my data, now I'm able to determine the type of relationship, if any, exists. So you'll see in this example, there definitely appears to be a negative linear relationship between the number of absences and final grades as a percentage. And that, again, should have been common sense, but we can now use data to back that up, right? If you're not in class, you're most likely probably going to fail, right? It's hard to learn if you're not there. All right, let's look at another example. Looking at example 21. Number of teachers in the thousands and number of pupils per teacher. So a researcher wanted to check for a relationship between the number of pupils per teacher and the number of teachers in thousands employed by the school district, and the data are from randomly selected samples. So we can see in school district 1, the number of teachers in the thousands, so that's 7,000 teachers. Each teacher had about 12.4 students. Another district had about 34,000, and they had 14.3 teachers or students. One was 9,000, had about 14.3 students. One was 8,000, had about 9.2 students. One was 16,000, had about 18.3 students. One was 15,000, which had about 18.3 students. One was 6,000, had 12.3 students. One was 14,000, had 12.4 students. Can't really have part of a student, it's just how the ratios go. One had 32,000 with 15.2 students, and one was 10,000 with 13.4 students. So again, we want to start off by drawing and labeling our X and Y axis, and then label in relation of the size of the variable, and then we're going to plot the data. So here we go. Oh, it did it for us. Dadgummit. Oh, it didn't. All right, cool. Let's do this together. So again, I'm going to draw my best ability of the first quadrant of the axis. Again, I'm going to do number of teachers Looks like the lowest was 6, and the highest was about 32. Nope, 34. 6, 12, 18. I could probably do that. I could probably start with 6 and then potentially go by 6s. So this would be then 12, 18, 24, 30, and this would be 36, which I believe 34 is the highest. So perfect. On the other side, I go from 9.2 to about 18.3. So maybe we start at 9 and then go up by 18. So then 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going to have to put 19 up there just so I can get that 18.3 in. All right, now we're going to plot it. So this is going to be 7. So let's do a different color here. So this would be 7. So it'll be a little past 6 and then 12.4. So roughly right here. 34. So about right here to about 14.3. Maybe about roughly there, give or take. Then 9, so 6, 7, 8, 9, about right here to 14.3 as well. 8, so 6, 7, 8, so in between those two, about 9.2, which would be about right here. Then we got 16. So there's 16 is probably about right there at 18.3. About right there. Then we got 15 right on the other side at 12.1. About right here. Then we got 6 on the dot at 12.3, so about right here. Then we got 14, so 13, 14. So just inside of this number here at 12.4, so about right there. 32 will be about right here at 15.2. And then we got about 10 right there at 13.4. All right, so now that we have our data plotted, now we have to come up with a conclusion. Does this look like it produces a relationship? So what you could say is maybe it does produce a positive. So I would argue that it does. I think it does have a positive relationship, but I would say it's not strong. So I would say there appears to be a weak positive linear relationship. I do argue that I think it definitely does have somewhat of a positive because it does look like in an idea, it's just very weak. You could almost argue as well that perhaps maybe there is no relationship at all. And I think you would be just as correct by stating that as well. All right, so that pretty much concludes chapter 2. As always, if you ever need more examples, please reach out, let me know. Everything seems to be going pretty well for the first week, but if you have questions, let me know. See you in the next video.